Okay, so in the previous video we introduced the process of completing the square. And for me, completing the square is not something that I use often when I'm solving quadratic equations. We'll have a look at a better option in the next video. Completing the square, though, is a really important technique when we're graphing quadratics and a really important technique in a few other areas. But today what we want to look at is how we can use completing the square to help us solve quadratic equations. Okay, and as I said in the previous video, essentially the process of completing the square turns our quadratic expression into a quadratic expression which has x just in one place, and so therefore that equation can then be solved by rearrangement, as we discussed earlier in this topic. So let's have a quick look at this example. So example 1, we first want to complete the square for x squared plus 6x plus 8. Okay, so remembering it's a monic quadratic, so we don't need to factor anything out. So it's x squared plus 6x. We're working out what needs to go in there, what do we need to add on and then take away to make the perfect square. And we still got our plus 8 out here. Okay, so remembering halving and squaring, positive 6. So half of positive 6 is positive 3. Squaring that is positive 9. So we're adding in 9 to make the perfect square. That's now a perfect square, but we can't just add in 9 because we feel like it and still say that it's the same as the previous line. So we have to take away 9 as well, so we haven't actually made any change. So the perfect square, x squared plus 6x plus 9 is x plus 3 all squared. Remember, we halve the plus 6 to work out what goes in the bracket. And then outside of the bracket we have minus 9 and plus 8, so that is minus 1. Okay, so then we want to solve x squared plus 6x plus 8. Now, in the previously, in fact, this is probably not the best example as the first example here, because if I was solving x squared plus 6x plus 8, the first thing I would do is try to factorise x squared plus 6x plus 8. And it does indeed factorise. It gives us x plus 2 times x plus 4 equals 0. Okay, and then we would use our null factor law, x plus 2 equals 0, which means x equals negative 2, or x plus 4 equals 0, which means x equals negative 4. And we get our two solutions. However, if we had a quadratic that doesn't factorise, we could, as a first step, complete the square. So instead, if we're trying to solve x squared plus 6x plus 8 equals 0, we complete the square and we say, well, this is the same as x plus 3 all squared minus 1 equals 0. And then we have a quadratic we can solve by rearrangement. So we add 1 to both sides. X plus 3 all squared equals 1. We take the square root, remembering that when we take the square root, we get positive or negative square root of 1. So that is positive or negative 1. And then we take away 3, so we get x equals negative 3 plus or minus 1. So in that instance, x equals negative 3 minus 1 is negative 4, negative 3 plus 1 is negative 2. And we get the same two solutions we got by factorisation. Now, if it will factorise, this is our first choice. If it won't factorise, however, this now gives us a method to solve. Okay. Alright, so let's have a look at some examples here. Solve each of the following equations by completing the square. Okay, so in this instance, looking at the first one, x squared plus 8x plus 6, if we would first, if the question didn't say by completing the square, solve the following quadratic equations, the first thing we would be doing here is trying to factorise the left-hand side. Factors of 6 that add up to 8. Okay, there aren't any, so now completing the square might be a way we could go. We also have another option which we'll look at in the next video. Okay, so let's focus on completing the square. So we don't need to factor out any coefficient of x squared. We have a monic quadratic, so it's x squared plus 8x, we need to add and subtract in here, plus 6 equals 0. Okay, so half of 8 is 4, 4 squared is 16, so we need to add 16 here, and then we can take away 16 to keep it all the same. Now the other thing some people teach is that rather than adding and taking away on the same side, if I choose to add 16 here to make that a perfect square, I could add 16 onto the right hand side and that would also keep the equation balanced. But that method only works if you've got an equation, and actually there are lots of instances when we're completing the square where we don't actually have an equation, so we don't have another side to balance out with, and so I prefer to think about adding and subtracting it on the same side, and that will work all the time. Okay, so now we've got our perfect square in those first three terms. It is x plus 4 all squared. And then we've got minus 16 and plus 6, so that is minus 10 equals 0. Okay, so we've completed the square, which now means we have an equation that we can solve just by rearrangement to get x on its own. So we're now going to add 10 to both sides. So we have x plus 4 all squared equals 10. We're going to take the square root of both sides, so x plus 4 equals positive or negative root 10. Now, if that third's not in simplest form, we need to simplify that third, but root 10, that's as simple as that gets. There's no square numbers that go into 10. And then x will be equal to, we want to take away 4, and remember I talked about in the rearranging, solving by rearrangement video, that we prefer to write the negative 4 in front of the square root rather than at the end where it might be ambiguous as to whether or not it's under the square root sign. So negative 4 plus or minus the square root of 10. And that's our answer. There are two solutions there, negative 4 minus the square root of 10 and negative 4 plus the square root of 10. Remember, root 10 is just a bit bigger than 3 because root 9 is 3. So this is negative 4 minus 3 point something and negative 4 plus 3 point something. It's two numerical values, okay? So there's your two solutions. You can leave them written like that. You don't need to write it out as two separate things, okay? All right, part B. Again, we want to solve the following equation. So we would be first attempting to factorise factors of 12 that add up to negative 6. Okay, factors of 12 are 1 and 12, 2 and 6, 3 and 4. They would both have to be negative to multiply to give a positive and yet add to give a negative. None of them are going to give negative 6. So factorising won't work here, so we then need to look at completing the square. So x squared minus 6x, what do we add in and take away? Okay, so halving and squaring negative 6. Negative 6 halved is negative 3, and square that is positive 9. And so take away 9. There's the perfect square. So we have x minus 3 all squared is the perfect square. Take away 9 and plus 12 is plus 3 equals 0. And then we try to solve this by rearrangement. So we get x minus 3 all squared equals negative 3. We take the square root of both sides, so x minus 3 equals plus minus square root of negative 3. And we get a big problem here because we cannot square root a negative. And so this quadratic equation has no solutions. We can't identify that just by knowing that the quadratic doesn't factorise. Okay? In part A, that quadratic doesn't factorise, but when we complete the square, we can solve it and find the two solutions. And they're irrational solutions that involve surds, which is why it wouldn't factorise. Okay? It's not until, so in part B, when it doesn't factorise, we don't assume, oh, it doesn't factorise, therefore it doesn't have solutions. We then complete the square, and in this version, it's very easy to see when we get to this solving process that actually we're going to be trying to square root a negative, and so there is actually no solutions to this quadratic equation. So remember, when we're solving a quadratic, it's possible to have two solutions like we got in part A. It's also possible to have one solution if we have a perfect square, and it's possible to have no solutions, and that's what we've got happening in part B. But we couldn't know that it has no solutions until we got to this point. Okay, part C. So we've got 2x squared minus 14x minus 5, so we need to factor out the 2. Now when we've got an equation, we've got, this is an easier step because we don't need to. So when we were doing this in the previous lesson, we had to factor out the 2. When we didn't have equals 0, we had to say, okay, well this is equal to 2 lots of x squared minus 7x, and then we're going to have our perfect square and minus 5 on 2. And we had to leave the 2 there and worry about factoring it out later. But now this is equal to 0, which means we can actually divide both sides of the equation by 2 rather than have to leave it sitting there and then worry about factoring it back in later. We can just divide everything by 2, okay? And so we don't actually need this line where we factor it out. We just divide everything by 2, dividing both sides of the equation by 2. We now have an equivalent equation. So what we're not saying here, we're not saying that those two things are equal to each other. Those two things absolutely aren't equal to each other. The second thing is half of the first thing, but these two equations are equivalent equations because we've done the same thing to both sides and therefore they will have the same solutions. Okay? Alright, so we've divided out the 2, so we now have a monic quadratic. We now want to factorise, so we're halving and squaring. So negative 7 divided by 2 squared is going to be 49 on 4, okay? And again, I want you to try and get good at being able to perhaps do that in your head. 49 on 4, so we need to add in 49 on 4 and take away 49 on 4, okay? So these first 3 terms here are our perfect square, and it is x minus, now remember it's half of 7, so 7 on 2 squared. And then outside of the bracket, we've got negative 49 on 4, take away 5 on 2. 5 on 2 is 10 on 4, so negative 49 on 4, take away 10 on 4, so we have negative 59 on 4 equals 0. Okay, so now we can solve. We've just got x here. We just want to get x on its own, so we're going to add 59 on 4, take the square root, and add 7 on 2. So we're going to have x minus 7 on 2 all squared equals 59 on 4. We're going to take the square root of both sides, so we get left with x minus 7 on 2 on the left. Sorry, don't need that bracket. And positive or negative square root of 59 on 4. Now, root 59, 59 is a prime number, that's not going to simplify at all, but root 4 is 2, so we're going to write this as plus or minus root 59 over 2. Okay. Alright, so now we're going to add 7 on 2, so x is 7 on 2 plus or minus root 59 on 2. Okay, that's perfectly okay as it is. We do, however, have this nice common denominator, so we could write this as 7 plus or minus root 59 all divided by 2. So either of these would be okay. So root 59, let's think about what's a square number near there. Root 49 is 7, root 64 is 8, so this is somewhere between 7 and 8. So we simply have two numbers here, 7 plus roughly 7.5 over 2, or 7 minus roughly 7.5 over 2. But in the current form with the surd, we can't simplify that any further. Okay, final example here, 3x squared plus 6x plus 5 equals 0. So the 3 is a problem, we can't complete the square yet. So the first thing we're going to do is we don't need to factor it out because we've got equals 0 on the other side. We can divide both sides of the equation by 3. So we get x squared plus 2x plus 5 on 3 equals 0. Okay, perfect square, completing the square. So we want to halve and square. Okay, so half of 2 is 1, and squaring that gives us 1. And so taking away 1, there's the perfect square there. X plus 1 all squared, minus 1 plus 5 on 3. So that's negative 3 on 3 plus 5 on 3, so plus 2 on 3. And then we try to solve. X plus 1 all squared is negative 2/3, and immediately the fact that we've got a negative over here, we won't be able to square root that, and so this quadratic equation has no solution. Okay, so the work today is from exercise 5H, so solving quadratic equations that wouldn't factorise by instead using completing the square.